Today we're going to talk about coordinate geometry proofs. Okay, we're going to actually prove using coordinate geometry. Last time we just set them up, right? Remember with some variables for the order pairs, we set them up so that it's easy to prove these things. But today we're going to actually prove. Okay. All right. So let's take a look at this here. As you can see, we have a isosceles triangle. If you have an isosceles triangle, well, let's read this. Kenneth, can you read this for us?
It is easy to verify that triangle OPQ is an isosceles triangle. Knowing this, we can deduce that medians OR and QS are congruent by using the midpoint and distance formulas.
Yeah, so if I give you this and ask, can you show that these medians, you guys remember what medians in the triangles were? Yeah, it goes from the vertex to the where? Midpoint to the other side. So, if I ask you to show that SQ is congruent to QR, what would you do to do this in this problem? Okay, how do I show that these medians are congruent? What would you do? Jocelyn?
First, I'd find the coordinates of S and R using the midpoint theorem.
Sure, you will have to find the coordinates of S and R using the midpoints, right? Then what do we do, Josh?
Oh, okay. Then you use a distance formula, see SQ and RQ are equal.
Yeah, sure, and then you find it, use the distance formula. That's easy, right? Now, would that prove that this is true for every isosceles triangle? No, and as we learned last time, this is a particular case, right? If you want to show this or prove this for every isosceles triangle, you're going to have to use coordinates that are made up of variables. Does that make sense? Because then that will represent every isosceles triangle. Does that make sense? All right, so this is what the second part is saying. How about David? Can you read this in order?
In order to give a coordinate proof that the medians to the legs are congruent for any isosceles triangle, and not just for the specific isosceles triangle above, you could use the figure below. Compare the general coordinates given in the figure below with the specific coordinates given for the triangle above. A coordinate proof follows.
And then we'll show you how to do that in coordinate proof. And of course, we're going to use something like this. Okay. So notice now this represents every isosceles triangle, right? And of course, to prove this, it's the same way as if you had a one particular case, right? It's the same idea. Just like before, we're going to do what? Find the midpoints, right, which are S and R. And we know how to find the midpoints of S and R, don't we? And then we find the distance. Does that make sense? And notice they call P A comma B and then Q 2A comma 0. And we talked about why this is 2A, right, guys? Remember? If I were to draw a vertical line through P, you know the distance from O to right down here, where this would be A, right? And so it could be twice, right? Does that make sense? All right, so let's do this, and let's do this proof. Let's first find the midpoints. Let's look at the order pair for S and R. Can you all do this? Okay, go ahead. Oh, wait. Everybody try. Write it down. Tell me the midpoints. And if you're done with that, go ahead and find the distance also. See if the distance is equal. Does that make sense? I mean the length. Look at the length. See if the length is equal using the distance formula. Okay, go ahead. Everybody try. I'll wait. So let's look at the midpoints. Who has the midpoint? S. What is the order pair? Okay, how about Jordan?
I got A over 2, B over 2.
A over 2, B over 2. How many people agree with Jordan? Yeah, that's correct, right? You could actually see that. Whoops, that's pretty straight. Well, okay, the other one is 3 over 2A comma B over 2, right? Because you could. Okay, look at S. Well, the O is at 0, 0. So you just basically, right, find the average of the x's and y's, and you get A over 2, B over 2. And then for R, if you look at P, it's A, and then x coordinate of P is A. The other is 2A. Add it together, divided by 2. Don't you get 3A over 2, and then B over 2? Okay, now that you see this, what could we have done to make this a little bit easy for ourselves? Everybody see what we could have done here? How about, okay, some of you see it. How about Leo?
You could have made Q 4A 0.
Yeah. And P?
2A 2B.
Yeah, you could have made P 2A 2B, then this would be 4A, right? Comma 0. Yeah? Now that we look at this, we go, okay, we could have gotten rid of all these, fractions. But they didn't. It's okay. But for you, if you're gonna have to find midpoints, do you think it's kind of good idea to have something as some multiples of 2s? Yeah, makes it easier. All right. It's not a big deal though in this case. It's not that bad. Okay, now I'll go ahead and find out the distance. Okay, so we know what S is, the order pair. We know the order pair for the R is, what R is, and then find the distance. Okay, go ahead, everybody try. I'll wait. Okay, and help each other out. It's fine. Okay, see if you get the same distance. Go ahead. All right, so how do you find the distance? How about let's find OR first. Grace, what did you get for OR when you find the distance of OR? Okay, did you get this? Square root of, first of all, I call this O as x of 1, y sub 1, and then R as x of 2, y sub 2. So it's 3a minus over 2 minus 0 squared plus b over 2 minus 0 squared. Isn't that what we get? Of course, the whole thing's square rooted, right? So what do you get when you simplify this? You get square root of what is 3a over 2 squared? What's that give you?
That gives you 9a squared over 4.
Yeah, 9a squared over 4 plus the other?
Squared over 4.
Yeah, b squared over 4. Whole thing square rooted, of course. Does that make sense? That's what we get, don't we? Now, if you wanted to, you could have actually simplified this a little further, right? Write as one fraction, which I would have done. They did. I don't know why. Okay, I would have written this as 9a squared plus b squared over all over 4, right? Anyway, what about the other? What about SQ? Okay, who's got SQ? Anybody have SQ? Yes.
When you simplify that
Hmm?
one,
Hmm?
can you like square root the denominator on?
Yes, very good. So you should have actually written, you're right. So I should have said square root of 9a squared plus b squared over 2, right? Because square root of 4 is 2. Very good. That's what I should have written. Very good. All right. So that's good. All right, let's write that out actually. Here we go. So you're right. You should have written this as, they should have done this as, this should equal to, what? Square root of 9a squared plus b squared all over 2. Now, can I cancel out like 9a with the square? No, you can, because why? Why not? You have addition in the middle, right? You can't cancel those out. The a squared and the b squared, you can't do that, okay? So that doesn't become 3a plus b. That'd be wrong, right? Be careful. Some of you did that, okay? All right, what about then, let's find the distance of QS. What do we get for QS? Anybody have that one? Okay. 3 people? 4? Oh, okay. Okay. All right. Who have it? Michelle, what'd you get? Yeah, same thing. Now, what did you get in before you simplify everything? Square root of?
A squared, A over 2 minus 2a
Uh-huh.
over 2,
Uh-huh.
sorry, 2a over 1 squared
Uh-huh.
b over 2 minus
Exactly. Isn't this what we get, guys? Right? So what, right, look, R is what? We said R was, right here, 3, oh wait, we're looking for the other one. So we said S was A over 2, comma, B over 2, right? So if you look at, we could call this as x of 1, x of 2, y sub 1, y sub 2. Isn't that what we get? Oh, they did it the other way, didn't they? Doesn't really matter, okay? So they really did this as x of 2, and then these are the x and y sub 1s. Isn't that what you get? Now, how do I simplify this? A over 2 minus 2a. What's 2a really? 2a over 1. What are you going to multiply top and bottom of this by so that you can simplify? Multiply top and bottom by 2, right? So when you do that, don't you get square root of 4a, right? A minus 4a. What is that? So you just simply get what? Negative 3a over 2 whole thing squared, what? Plus b over 2 squared. Isn't this what you get then? Would you not agree? And of course, when you simplify this, you get this, right? Same thing. So therefore, what do you know about these two? Length. They are congruent. So therefore, we have shown that for every isosceles triangle, right? This is the medians are always going to be congruent. Easy. Okay. Now let me show you something interesting. So with this kind of proof, it's kind of nice because what you could do is you could actually put them into a computer. Like this, and look at all these things. You know, it's like A, B, C. These, I just punched those in. That's nothing difficult. You know how you got all these things here? Like, you know, the coordinate of S and coordinate of R. I just put that in. It's the right this computer program, right? And then all you have to do is, if I change the value, notice if A and B, if A is 0, B is 4. Look at that point is the median. You can kind of think about it. Look, as I change the A, that's what we get, right? The triangle, and you see the two medians, right? And as you can see, I could change the value of A and B. Guess what this was? Remember this point? What was that point? A comma 0, and guess what this point was? You could go back to this. What was that? AB. So that's what I did. I just put this into the computer. That's kind of nice. That's what's nice about this coordinate geometry proof. You could actually put this in, and right, it'll work the way that we expect it to. Right. Now I'm changing the value of A. As you can see, if I make it, I can make it a little bit right skinnier or wider. Make it taller. Or anyway, but does this show that the two medians are congruent? Not really. It just shows the triangle, right? It kind of moves the way it should be, right? If I could change the value of A and B. But how can I show that they have the same length in terms of these medians? Well, what I did was I actually graphed that line here. One of the medians, the length, I graphed it as a horizontal line. Is that okay? There's that one of the length, okay? And I did the same for the other. And of course, if they were different, how many lines would you see? 2, right? But if they were same, wouldn't it be right on top of each other? So if I grab this one, let me look at this equation. Let's change the color. Okay. Right now it's red. Let's change it to blue. Okay. So if I grab this, look what happens. Do you see? So, right, I could hide it, and then now if I grab it again, it goes right on top of it. That means what? They have the same? No. This is the value of the actual length of these medians. So they're equal, right? So no matter what I do with A and B, right, it verifies that we have the same length of the median there. Does that make sense? Anyway, that's why this coordinate proof is kind of nice. You could actually show it graphically using computer programs, right? Anyway, you would do something like this later. All right, when we get a chance. So does this make sense? So that's what it shows. Oops. Okay. All right, let's move on then to the next part. Can somebody read this for us? How about Nico? Can you read this for us?
It is possible to prove many theorems of geometry by using coordinate methods rather than the non-coordinate methods, involving congruent triangles and angles formed by parallel lines.
Mm-hmm.
Coordinate proofs are sometimes, but not always, much easier than non-coordinate proofs.
Mm-hmm.
For example, compare the proof in example 2 with the proof of theorem 511.
Mm-hmm. And it makes sense. Good. Yeah, it makes sense. Sometimes you could, of course, you cannot always use coordinate geometry proof for everything, right? But sometimes, some of these proofs, it will make it easier. Is it going to make it easier for every proof? Not really, but some of them will. So, but take a look at this one. If you remember this from this long time ago. Remember this proof where? Okay, let's read this for us. Let's read this. Who wants to read this example? How about? Go ahead, Josh.
Prove that the segment joining the midpoints of two sides of the triangle is parallel to the third side and is half as long as the third side.
Mm-hmm. Do you guys remember this? We did this, and I don't know if you remember this, but this was rather a little bit longer than other proofs. You guys remember that? Okay, but if you actually do this using coordinate geometry proof, it's not that bad, because all you have to do is what? Show that Mn is, first of all, what? Parallel to OQ, and that's pretty easy to show, isn't that right? You just look at their slope. And again, if I want to show Mn is half of OQ, all you have to do is find the length, right? Using the distance formula, correct? So it's much easier this way actually to prove it. Remember, if you remember back when we proved this directly, yeah, right? Using just 2-column proofs, it was rather a little bit longer, right? Of course, this time it'll be much shorter. Does that make sense? And let's actually do this one then, okay? Turns out, because Mn and OQ are horizontal lines, it actually makes it a lot even easier. Why? What do you know about two horizontal lines? Slope of a horizontal line? Yes. It's 0. Also, isn't it easy to find the distance of a horizontal line? How do you find the distance of a horizontal line? What do you know about the y's? Y's are always going to be? Not 0. Same, if they're horizontal. for OQ, yeah, y will be 0. But MN, the y won't be 0, right? But we know that y is the same. So all you have to do is worry about, yes,
Just find the difference in x coordinate.
find the difference in x coordinate. Right? That's the distance of the horizontal line. You guys remember that? All right, so let's first of all find then M and N. That's what we got to do first, right? Well, M and N are the midpoints of, right? OP and PQ, correct? Okay, so go ahead. Everybody find the midpoints. And then after that, go ahead and find the slope and the distance. Okay, go ahead. And like I said, because it's a horizontal line, it's much easier. Go ahead, everybody try it. I'll wait. Okay, everybody go ahead and try this. Okay, so somebody tell me then the order pair for M first. What's the order pair for M? Again, as you see, actually you could have made this a little bit easier, right? How could you have done this a little bit better? Instead of AB, Jocelyn?
You could make PB 2A, 2B.
Yeah, 2A, 2B. What about C? You could make it 2C also, because you're going to have to find distance of P and Q also. So yeah, C2, right? You make it 2C. Anyway, you don't have to, right? But it's easier that way. This time they didn't again. But for your homework, I think I would do that. Anyway, so what's the order pair for M in this case? Brandon?
A over 2, B over 2.
A over 2, B over 2. What about N? The other Brandon, what do you think? What's the order pair for N? It's A over 2, B over 2 for this M. What about N, Brandon? Well, you just use the midpoint formula, right, Brandon? So you got AB over here. This is C comma 0. So what's the x coordinate of N?
A plus C over 2.
Yeah, A plus C over 2. The other is?
B plus B over 2.
B over 2. B plus 0 over 2. Exactly right. Is that okay? Well, that's what we get. Easy enough? So then, let's look at what we have to prove. We have to show that MN and OQ, they're parallel. This case is really easy. What's the slope? It's really easy because what's the slope of MN, class? 0. It's a horizontal line, right? Look, it could actually plug into the slope formula. It's 0, right? Because the y coordinates are equal, same. What about OQ? Again, you're going to get 0 over something, right? It's going to be 0. So they both have slope of 0, so they're parallel. Yeah, they're both horizontal lines, right? Yes?
On our homework, do we have to somehow like prove that their slopes were 0?
You could just, and it's, you know how it says y on your book, so you gotta explain why. If you don't want to actually plug in and show it, you could say it's because they have the same y coordinates, or you could say that because they're horizontal. Okay, yeah, so some explanation you need to put. Okay, all right, and of course that's not all. We're not done, are we? We need to also show that MN is half of OQ. So what is the distance of what's the distance of OQ? That's easier. What's the distance of OQ? It's a C, right? 0 to C, right? The y is the same. So the distance, the length of OQ is C. What about the length of MN? How did you know it's C over 2? Yeah, it's just difference of the x's, right? Which one do we do? Do we do A over 2 minus A plus C over 2 or the other way around? Other way around because why? Because isn't M on the right side of N? So N has bigger value of X than N, right? In this picture. I mean, obviously it could have been somewhere else, but it doesn't really matter because really, when you look at the distance of M and N, it's the absolute value of it anyway, right? So, okay, so there you go. As you can see, the other is C over 2. The distance of OQ is C, right? That's what we get. Any question? So really, to find the horizontal distance is the difference of the x's. We take the absolute value of it, right? You guys remember that? All right, any question? Do you see what to do for your homework tonight? Okay. All right, let's do one last one. Okay. By the way, when they give you these kind of questions, do you think they will give you this picture? No, they're not going to give it to you, right? They'll just give it to you this way. So you have to come up with the no. So this you have to come up with the order pairs, right? That's what you have to come up with. That's what we worked on last time, remember? So let me give you one. Okay, here we go. This one's kind of interesting. All right, so what I meant is they give you something like this without any sort of diagram. You have to come up with a diagram and, of course, with the order pairs, right, with some variables, you know. So it says prove that if the diagonals of a parallelogram are congruent, okay, prove that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So this one's kind of interesting. It's not so straightforward as the other one, but write this down and think about what's given to you and think about what you need to prove. Okay, so go ahead, write this down first. And think about what kind of diagram should we need. Okay, go ahead, everybody think about this. Write it down. Okay, so when we draw this diagram, guys, how many people think that we need to draw a rectangle first? Okay, how many people think we should draw a parallelogram first? Not too many, just one person? Leah is correct. Yeah, because look what's given. Leah, why did you say we should start with a parallelogram?
Because the question starts with parallel.
Yeah, what's given to us is a parallelogram. They're saying we have a parallelogram, and this parallelogram happens to have the what? Diagonal as? I mean, diagonals are what? Congruent. So that's what's given to us. So we have a parallelogram, and we have this diagonals of these parallelograms are congruent. We have to show then, if this is true, that it must be a rectangle. You see, that's what we're trying to prove.
I'm just gonna draw a circle over and it looks like a rectangle.
That's probably not a good idea. So because, yeah,
We're all right, because parallelogram is a rectangle.
parallelogram is a rectangle.
The rectangle's not
No, not every parallelogram is a rectangle, is it?
Oh, no.
So be careful. The other way around is correct. Okay, so yeah, so be careful. Now, so how are we going to draw this parallelogram? Well, I will do something like this.
I did it wrong.
Okay, do you see? Whoops, I was going to hide this. But anyway, do you see why this is a plus c right here? Okay, why is this a plus c? This is easy to understand that this is a comma 0, this is c comma b. Yeah. Yeah, you guys remember we get a triangle over here, right? What is the distance from here to here? C. Therefore, if this whole thing is then, right, here to here is a, you gotta add c to that, right?
Oh.
Okay, so please be careful, this part, right? This is a plus c. Don't call it like d, don't put a new variable, right? This value right here, the x coordinate of this b, is going to be a plus c because, again, I could put a dotted line over here, right? Look at this line. What is the distance from here to here, guys? This is a. What is the distance from here to here? C. That's why this is a plus c.
Yep.
That's important. Don't mess that up, otherwise you're not gonna get it right. All right. So when we have this, of course, we have to look at the diagonals. What about the diagonals do we need? We need the length of the diagonal. Okay, do we know how to find the length of a diagonal? Go ahead, everybody. Use the distance formula. Tell me what we get. I'll wait. And how do we show then if the diagonals are congruent? That's what's given. Why must this be a rectangle? Go ahead. Think about how that works out. Okay, I'll wait. Who can tell me then the length of OB? How about Jack? What'd you get?
Rad a squared plus b squared plus c
Rad A.
squared.
Really?
No.
Isn't it a plus c squared?
Can't you?
Oh, can you cancel those out?
No.
Yeah, you got an addition in the middle, so you can't cancel the square root, and it doesn't become a plus c plus b, does it? Please be careful, guys. Yeah, they don't cancel out. There's an addition in the middle, so you get square root of a plus c squared plus b plus c. Oh yeah, you can multiply this whole thing out, and then yeah, you get a trinomial inside. Yeah, you could do that. Yeah, that's fine. But you can't cancel those out, can you? Jack, what did you get?
A squared plus b squared plus c squared.
Yeah, that's.
Rad a squared plus b squared plus c squared.
A squared plus b squared plus c squared, really?
That's what you did.
Oh, when you simplify?
Yeah.
What is a plus c squared, class? Is it a squared plus c squared? No, you get a trinomial, don't you? You get a squared plus ac, right? How many of those acs do you get? 2. So you get a squared plus 2ac plus c squared plus b squared. Be careful. Okay, so I thought you meant this, but still it's wrong, right? So. All right. What about ac? What's the let's just leave it this way for now. What's ac, guys? Did you all get square root of? Not same. You get a minus c this time squared plus b squared. Isn't that what we get? Yes? Okay, so what do we know about these length of these diagonals? From given what? They told us they were what? So
They lied.
I'm sorry? What? Look, alright, look at what it says. Prove that if, here's the given, the diagonals of a parallelogram are congruent. That's given. Right? It's our hypothesis, right? So we know these two are they're equal. So if they're equal, what do you know about the radicands of these two square roots? If OB is equal to CA, then square root of this has equal to this, right? right? In order for these two square roots to be equal to each other, what's inside must be equal. Would you not agree?
Yeah.
Why? You just said it equal to each other. Aren't these two equal to each other?
Mm-hmm.
That's given, right? Well, if that's true, what's inside is has to be equal to each other. No, right?
Yeah.
So, well, I simplified it. I multiplied it out, right? And when you simplify, you should get 2ac equals 2, negative 2ac. Well, they're kind of like terms, aren't they? Let's add them together. You divide both sides by 2, and then you get 2ac equals 0. Can I still divide it by 2?
Yes.
Only way for this to be true is if a times c equals 2, 0. Would you not agree? Right? Because I could divide both sides by 2 here, right? What does that mean? This gives you two possible ways for this to be true. If this is only true if what? Do you guys remember zero product property? Yeah, if A is 0 or if C is 0. That's the only one. That's the only possibilities. Turns out, okay.
I got it.
Okay, so if A is 0 or C is 0, that's the only way for these two diagonals to be equal to each other, right? If this is true, can A be 0? Let's go back to our diagram. Picture. Can A be 0?
No.
Why not?
Because
Why can A be 0, guys?
0, 0.
Yeah, if A is 0, look, this will be 0, 0, so A will be, what about this? A plus C, that will be C comma B. So you will get a, you will just get a line, you get a segment. Is that a parallelogram?
No.
No. So A can't be 0, so that's, we have to throw out that, we can't use that, right? What about C? What happens if C is 0? No, if C is 0, then this becomes what? 0 comma B, which will be right here. What would this be? A comma B, so don't you get a what? Rectangle. So that's how that works out. Here we go. So, hey guys, we're not done. Hello. Okay, listen. Hello. Hey guys. Okay, so A can't be 0 because A cannot be at the origin, right?
Yeah.
Oh, hold on. So therefore, only way for this to be true is if what? C is equal to 0, then you get a rectangle. You get 0, 0, A 0, B, AB, and 0 comma B. Does that make sense? Can you do something like this for your homework tonight?
Yeah.
Have a great day, guys. Thank you.